All right, welcome back to another video by John Science. So here I'm doing a tutor class for my student, his son, and we are at 1.5. Talk about formal charges and how to calculate them. So basically, we did the structures. Miss Han, are you there? Hello. Please turn on your microphone. Okay, just don't turn it off. Now, so before we saw the structures like, for example, NH4 plus, or something with a minus, like NO3 minus, SO4 2 minus, something like that. So those minus or plus, these are called formal. Those are formal charges. So how do you calculate them? Formal charges. So many Lewis structures incomplete, of course. Sometimes you don't have like full octet for everything. Sometimes life is unfair. So many Lewis structure incomplete. So we have to assign them formal charge, plus or minus, because not all of them are achieving a full octet, and not all of them have, like, you know, neutral, everything. So we have to assign them formal charge. So calculate the formal charge on an atom in a Lewis structure is simply a bookkeeping method for its valence electrons. So it means you have to calculate according to its outermost shell electrons or valence electrons. Now let's read this one. Miss Han?
Yeah.
Can you read it out?
First, we examine each atom examine each atoms, and using the periodic table, we determine how many valence electrons.
It's examine and determine. Be careful. Determine.
We determine how many valence electrons it would have if it were isolated atoms. This is equal to the group number of the atom in the periodic table. For hydrogen, this number equals 1. For carbon, it equals 4. For nitrogen, it's equal 5. And for oxygen, it equals 6. Next, we examine the atom in the liquid structure, and we assign the valence electrons in the following way. We assign to each atom half of the electrons it is sharing with another atoms, and all of its unshared electron pairs.
So basically there's a formula here. There's a formula here. Formal charge equal to the number of valence electrons, everything, minus half of the number of shared electrons. So basically, how many bonding? Look at the bondings. So you count those shared electrons and you divide by half. And then minus the number of unshared electrons, which is the lone pairs, you know.
Yeah.
So continue, please.
Where F is the formal charge, Z is the group number of the element, S equals the number of shared electrons, and U is the number of unshared electrons. It is important to note too that the arithmetic sum of all the formal charges in a molecule or ion will equal the overall charge on the molecular or ion.
On a molecule ion. The arithmetic sum of all the formal charges in a molecule ion equal to overall charge. So the whole thing has to be equal to all the formal charges, the little ones in there. Let's consider several examples to show how it's done. The ammonium ion, so NH4. This is one of the most simple example. So you can see here, ammonium ion NH4 plus So in here, you can see that nitrogen's everything is shared. It doesn't have any lone pairs at all, right?
Yeah.
So no unshared electron pairs in this case. So so what do we have here? For hydrogen, for the hydrogen only, valence electron of free atoms is 1 because group 1, right?
Yeah.
Subtract a signed electron, which is the one that is shared. So this is 2, but half of that is only 1. And there's no lone pair for hydrogen at all, so 0. So the formal charge on each hydrogen is 1 minus 1 equal to 0. So 0, 0, 0, 0 for each of the hydrogen. How about for nitrogen? Nitrogen is group 5, so valence electron of free atom is 5. And then it has 8 electrons to share with the others, isn't it? Eight electrons to share with the others. So half of that is like 4. So 5 minus 4 is plus 1. So that's why the formal charge on nitrogen is plus 1. And the overall charge on iron, so for hydrogen is 4 times 0 plus 1 in here. So overall charge on iron is plus 1. That's why we see the plus in here, right?
Yeah.
Okay, now try the nitrate ion. So, okay, unshared electron pairs. Okay, let's try this case now. Can you explain this? Okay, let's look at oxygen first. Look at each oxygen first. So we have this case. Nitrate ion. So let's look at the oxygen on the top. What do you see? Three lone pairs, right?
Yeah. 3 lone
So
pairs.
it means 6 minus 6 here. And it formed the bonding with 2 electrons here. So half of that is 1. Half of 2 is 1. So 6 minus 6 is 0. Minus 1 is minus 1. So this oxygen has a formal charge of minus 1. The same thing happened to this oxygen, so minus 1 as well. So you see, here it's set minus, here it's set minus. For this oxygen on the bottom left, 2 lone pairs is 4, so minus 4 here, and it has a double bond, so 4, and half of that is only 2. So 6 minus 2, it's 4, minus 4 is 0. So this oxygen is completely neutral, it doesn't have any formal charge at all. How about the nitrogen? So group 5, so for the nitrogens, we have 5 minus, it has no lone pairs, right? So, and then half of
0.
half of what? So
6.
half of 8, actually 8, because you have 8 surrounding it, right?
Yeah.
So equal to 5 minus 4, it's plus 1, isn't it?
Yeah.
So that's why this nitrogen has a plus 1 formal charge. As you can see here, formal charge for nitrogen plus 1. So totally, minus 1 on top, minus 1 bottom right, and then plus 1 here. So totally, the charge on ion is minus 1.
Okay.
Is it understandable?
Yeah.
Okay, I think we can try others, but here we have water and ammonia. Let's look at this case now. Can you describe it?
Okay, so for oxygens, it have 6 valence electrons, and for the share electrons, it have 4 share with the hydrogen.
So half of that,
So 6 will minus with half of 4, and it's have 4 and share 2.
yes.
So 2 long pair outside, so it's 4. So total is 0. And for hydrogen, it just have 1 valence electron, but it have 2 share electrons, but no share unshare. So it will be 1 minus 2 half of 2. So it will be 0 2.
So totally
yeah,
there's no charge for the molecule, it's 0.
Yeah.
And for ammonia, have ammonia.
Ammonia for oxygen is have 5 valence
Sorry,
electron.
ammonia, NH3, ammonia.
Ammonia.
Yeah, NH3.
So for nitrogen, it have 5 valence electron, but it have 6 electron share with hydrogen, and it have 2 lone pair. So it will be 5 minus 2 half of 6, and minus 2 it will be 0. And for hydrogen, 1 valence electron again, and just 2 electron to share with nitrogen. So 1 minus 2 half of 2 will be 0. So no charge for that one too.
Exactly. So ammonia and we have ammonium ions here. So of course ammonium has a charge, but ammonia doesn't have. Right, so you have a practice problem here. Write a Lewis structure for each of the following negative ions and assign the formal charge, the formal negative charge to the correct atom. So you have to write that charge to the correct atom. So which one? C, O, or H, or something like that, you know. All right, I think, let me just, okay, you can share.
I already did it.
Sorry?
I already did.
Oh, you did it already. Cool.
Yeah, so I can share the result with you.
All right, you can share the whiteboard. Why blackboard? This is whiteboard.
Okay.
Have you?
Yeah, I share screen.
Okay.
Okay.
Interesting. Okay.
Here we go.
Ah, there you go. I think I have to stop my share in order to see your share, I think. Alright, so NHC, H3Cl minus. Yeah, look legit. Good. NH2 minus. Something. 5 minus 4, 1. 1 minus 2 is minus, okay. Good. CN cyanide. Cyanide. 4 minus 2. Actually, for the cyanide, I think the minus should be on the C.
This one?
Yeah, for on the C. No, for the cyanide, the CN on top.
Oh, it's right here.
Yeah, because if you calculate, it's on the C actually.
Yeah, the C, because it's 5 already.
Yep. Oops.
Okay. Sorry. Can you see it?
Yeah, see it clearly. Very.
here.
Okay, good. Now let's move on to the next one. I think for the previous one, which one is the previous one? Can you just move to the left, please?
Okay, here.
Okay. For this one, the minus should be on the nitrogen, I think.
Where's that? What do you
For
want?
for NH2 minus, the minus should be on the nitrogen, I think.
H2 minus. Where's the formula that you mentioned?
NH2 minus.
Right here.
Yeah,
So
I believe that the
okay.
minus should be at the N. Okay. All right. So.
Okay. Let us stop share.
Oh.
Okay.
Oops. You should share again now.
Yeah, I stopped sharing. Do you want that I continue to share?
Oh, yes, that's fine. I think I believe so.
Yeah.
Now, so a summary of formal charges. So summary of formal charges group, you can see here. Let's see formal charge of 0 first. Let's look at the middle. So
Can you share your screen?
a moment. There you go. So we talk about 1.5a summary of formal charges. So normally we have formal charge of 1, plus 1, minus 1, or 0. But let's look at 0 first. So for boron group 3, right? So it should form 3 bonding. So there's nothing, no charge at all. If it's like this.
Yeah.
Carbon group 4. So it should form 4 bonding. So this is a perfect situation when you have 4 bonding surrounding it. So in the case if it doesn't form 4, only 3, it will have positive here, formal charge 1. If the carbon has a lone pair here, this has a negative. But to be honest with you, don't need to remember these things. Basically, just do exercises and you will determine its formal charge. This is just a summary. But how can you remember all these things? Just do exercise. You will know it. Alright, so assign, okay, let's go to practice problem 1.11. Assign the proper formal charge to colored atoms in each of the following structures. Alright, let's write it on the whiteboard and then we see. We have 8 of them.
Okay. Okay, let us take a picture of that and
Say again?
let us take the screenshot of that
Sure,
and
sure, and then
yeah, and I move to the GoodNote to do it. Okay, so now I share.
yeah.
Okay.
How can I swap to your shares? Weird. Recommend sharing option.
Okay. Let's open.
I think only one person can look at the screen and share the same at one time, I think.
Okay, you can see is my. You can see my sharing.
Okay, I see you're sharing now. Perfect.
Oh.
Alright, let's draw it.
Okay, for this one.
Are you using MacBook?
Yeah, I'm using the iPad right now.
Oh, sometimes I think iPad's good too. Why not?
Yeah. And for this app, I need to pay it for a month to study. Okay. For
Nothing good comes for free, remember that.
F1.
For life, nothing good comes for free.
Yeah. But sometimes we need to pay something to save something.
Exactly.
Like when I use that one, I don't need to buy book or anything. when I go in school, I just need that to go with me. I don't need any paper or any, yeah, it's useful.
Well,
Okay, so,
in this world, nothing comes for free.
yeah. Yes. This 1, 2, 3, 4, or so. One more is here. 1, 2, 3. I think it's. Oh, do I need to draw the number like that? Do you need to draw the number or just the minus or the plus? But I think it's no charge.
I think for G is no charge. Yeah, true.
Yeah, no charge. So right here, 1, 2, 3, 4, 5, 6, 7. So here.
I think you might want to look at B again.
B, right here, B. 1, 2, 1, 2, 3. 2, 3.
It's a plus.
4. 1, 2, 3, 4, 5.
Yes, a
This
plus.
have 5
You might want to look at B, question B again. The exercise B again. No. I mean E.
E, this one.
Yeah, 5 minus 4, and then oh yeah, it's plus 1, not minus.
Okay.
It's a plus, yeah.
Yeah.
Good. And then move on.
Okay, here.
F.
1, 2, 3, 4. Okay, minus.
It's plus 1 over there, the oxygen.
This one?
For F, yeah, plus 1.
Where's plus 1? 1, 2, 3, 4, 5. 5 electron right here. And miss someone, so okay, plus.
How about
And
this
right
one?
here. Plus 2.
Sure about that?
Wait. 1, 2, 3,
5
4.
minus half of 8, it's like 4, so plus
5.
1. Oh yeah, plus 1.
Yeah,
No
plus.
one cares. Okay.
Okay, I stop share mine.
I believe that A is wrong.
8?
I think A for question A, yeah.
Okay.
For question A, you wrote a minus, right?
Yeah.
But actually it says like 4 minus half of 6, it's 3. 4 minus 3 is plus 1 actually for question A.
Yes, I plus 1 right here.
But you wrote minus for question A.
8? A right here?
Yeah, it should be a plus. Anyway, let's go back to
Okay.
alright, good. It's good now.
Okay.
Let's go back to, okay, we have next part, which is isomers. Different compound that have the same molecular formula. So we have isomer, iso mean the same, me mean unit. So basically they have the same molecular formula, but in fact they are connected differently. So please read this part. It's all like, just read it and you will get it. Okay, okay, back here. Okay, so Han, can you tell me about like constitutional isomers and other things?
Isomer. So
Constitutional isomers, yeah.
Yep. Okay.
So one molecular formula can give yield, can basically yield so many different constitutional isomers depending on the connectivity or how the atoms are bonded together. So we have the situation of acetone and propylene oxide. One is a paint solvent. Acetone is like nail polish remover, you know.
Yeah.
And
I know.
propylene oxide, food grade thickener, foam stabilizer for beer. So they all have the formula C3H6O, and of course they have the same molecular weight, but they are different molecules, and they perform different function as well, depending on the connectivity, how the atoms are bonded together. Yet, because of the way the atom bond together differently, they have different boiling points and, of course, different chemical reactivity. So they react differently. And of course, because of that, they lend themselves to different practical applications.
Yeah.
Okay, so looking at the molecular formula, you only have like what? You can only look at the molecular weight, that's it.
Okay.
And how many atoms it has, but you have no information about like how the atoms are bonded together and what are their chemical properties and physical properties. So molecular formula like C3H6O give you a very limited knowledge. So that's why we have to learn about constitutional isomers. Now this is the structure of acetone here and propylene oxide. So I just moved the H on the right down to the C at the center. And then the oxygen form the bond with that C. So you have a situation like this. Propylene oxide. Okay. So they're different. And can I ask you which molecule is more reactive? Can you guess?
I think the first one, the acetone, because
Why?
it's have the first one, the acetone,
Why do you say so?
because I think it's have the double bond. So
Yes, but in my opinion, the second one is more reactive because you look at this bond. It's oxygen C and C here. This triangle, 60-degree angle, like a 60-degree angle like this. It's very tight, right?
yeah,
So it's likely to like break out easier. So molecules that look very tight, like a square or a triangle, they tend to be extremely reactive because you will learn it angle strain.
yeah,
The stress between the angle, right? So in my opinion, the propylene oxide is a more reactive molecules. Acetone, yes, because of double bond, yes, but it's not as much reactive as the one on the right. Now let's move on. Of course, constitutional isomers, because the atoms are bonded differently, they usually have different physical properties, which is melting point, boiling point, and density as well. And different chemical properties, which is how they react with things or reactivity. So let's look at this one. C2H6O. You have to write structure formula for these isomers. Structural formula is not a way to say constitutional isomers, you know.
yeah.
So look at this one. How can you say? First, write the carbon first. The carbon. And so just write the carbon first. So you have CH3 here, and oxygen in the middle. This is one of them. And if the oxygen moves to the right, you have this case of ethanol.
Okay.
Just try it and you will see.
So 2 of that is correct. But so is that 2 ways to dry it?
Mm-hmm.
What's the difference for that? It's different about the physical property.
Mm-hmm. Of course, they are different and physically because you see ethanol, the oxygen there it's bonded to an H, right?
Yeah.
So according to electronegativity, it's positive at the oxygen and negative at the oxygen and partially positive at the hydrogen. So that OH can form hydrogen bonds with other molecules, right?
Yeah.
But for dimethyl ether, that oxygen is not bonded to any hydrogen at all, isn't it?
Okay.
Its ability to form hydrogen bond is limited compared to the ethanol case. You know what the
It's limit for how many?
So it means dimethyl ether can it's normally a gaseous. Normally it's gaseous. It can become gas very easily compared to ethanol. What's your question?
I mean the limited for compare
Forming
with
hydrogen bonds. For forming hydrogen
Yeah.
bonds. Okay. There you go. At room temperature and 1 atm pressure, which is normal pressure, dimethyl ether is a gas because it doesn't really form much hydrogen bonds with itself and water or any molecules surrounding it. So it's spread out easily, so become gaseous, right? But ethanol, because of OH here, it forms hydrogen bondings easily with itself, with all the ethanol molecules or with the water or anything else surrounding it. So ethanol is a liquid. Makes sense, right?
Yeah.
Okay. Which of the following compounds are constitutional isomers of one another? So you have 5 cases. How do you know if they are constitutional isomers of one another?
Which one's compared constitutional?
You have to write it in full. You have to write it in full, like C, H, and then O, so something. Don't write it in stick formula like this. You have to write it in full, and then you count the number of atoms in each of them and compare.
Okay, I think B and D is isomers.
Of course, B and D have the same molecular formula, but they have different connectivity. ACE also have the same formula. A, C, 3C, and E, yeah.
Yeah. Okay.
So ACE and BD, yeah. All right.
Yeah.
1.7, how to write and interpret structural formulas. So basically, constitutional formulas or structural formulas, same way to write it. But there are ways to write and interpret structural formulas. You can write it in a ball and stick models, but this is a model, you cannot write it. you have electron dot formula, dot like that. Or you can write dash formula. Or you can write just condense them together like this, condensed formula. Or you can write bond line formula only like this, stick formula, I would say stick formula. Anyway, all of them are fine. Condensed formula, bond line formula, or skeletal formula, like a skeletal, skeleton, are also important too. And this is example using propyl alcohol. Propyl alcohol, or also called propanol. So we have ethanol, so we'll have propanol, 3C with an OH. So the older terms for isomers of this type was structure of isomers, but the IU pack now recommend the use of term structural when applied to constitutional isomers to be abandoned. They're trying to abandon it. So now we call them constitutional isomers now. New name, huh? Longer.
Yeah. I cannot remember that.
Slowly you get it. The dot structures are time consuming to write. So that's why people write quicker, dash, or condense, or bone-like, or stick formulas I use more often. But when you are quick like that, sometimes it's not that useful. When people write like dot formula, you can see the electrons, you can see the unshared electron pairs, you can see how they form the bonds, something like that. And it can be more useful to understand how the reaction happens if you write like dot formula,
Yeah.
So it's a good idea to be in the habit of writing unshared electron pair as well. I think I would say try to write the dot formula more. Now, more about dash structural formula, like dash line. Dash structural formula have lines that show bonding electron pairs and include elemental symbols of all the atoms in the molecules. So, so what they are trying to say here is when you have a single bond, things can just move freely like this, right?
Yeah.
Things can just move freely like that. So the OH here can move to this side freely, or this one, it can move up. See, it can move up like this. They're all equivalent as long as the atom is bonded to each other in the same way, right? But they can just rotate relatively freely with respect to one another.
Yeah.
This one only applies to single bond. Just imagine it like this. If you have a pen like this, things can just move freely like this, right?
Yeah.
But when you have the double bond, things start to be difficult to move, right?
Yeah.
Let alone
It's
like
not
triple bonds. So that's just a way to remember. If single bond, they can move freely, rotate freely with respect to one another.
Yep.
So you can write in any way, going up like this, or upside down like that, or they move, whatever. Okay, now we talk about bond angle, 90-degree bond angle. So if you have watched my video about bond angles, you can see that when a carbon is connected to 4 things surrounding it, right?
Yeah.
But in space, it does not have a 90-degree bond angle, just like this, they don't. But in reality, it looks in reality it looks like this. Oh, a moment. In reality it looks like that, isn't it?
Yeah.
In reality it looks like that. To ensure that the bond angle is the maximum possible, because you don't want to have like very tight bond angles. When they are too near to each other, they repel each other because bonds are formed by electrons, right?
Yeah.
And electrons are negative, they repel each other. So that's why you have this kind of tetrahedral structures, 109 degrees, as I told you in my video.
Yeah.
Alright, please read all of the structure formulas.
Structure formula above are equivalent and always represent propyl alcohol. That structural formulas such as this indicate the way in which the atoms are attached to each other and are not representations of the actual shapes of the molecule. This is propyl alcohol. Does not have 90-degree bond angles. It has tetrahedral bond angles. That structural formulas show what is called the connectivities of the atoms. Constitutional isomers have different connectivities and therefore must have different structural formulas.
Of course, constitutional isomer, they must have different structure formulas. So it can be either like this, or the OH move down, can be like that. Or you can bend this C like this.
Okay.
I mean, they're all equivalent. Dash formula. And you have isopropyl alcohol is the constitutional isomer of propyl alcohol because it's atom connected in different order. So basically, this is isopropyl alcohol. Iso means the same. So you can see the OH in the middle C, right?
Yeah.
But for propyl alcohol, the OH is connected to the N, the C at the end, right?
Yep.
So in practice, they are different molecules, but they are constitutional isomer of each other.
Yeah.
Right. Okay, let's continue now. Okay, so you are asked to write the constitutional isomers of C3H8O. So you are given 2 already. You have to write a third one. Try to.
You wanna?
Yeah, I can stop share and you can show the board.
Share. Oh wait, 1 second. So okay, whiteboard is okay because I use the pen right now.
Oh.
What do you want? I draw. Do I want to draw?
Yeah, please. C3H8O.
C3H8O. C3H8O.
Okay, maybe just write black. Yeah, use black.
This one?
No, C3H8O.
C3, okay. H8O, right?
Yes.
Okay. No. Okay. Is that correct?
That's one of them, yes. Now, please move. I think now it's better to move the O, oxygen in the middle.
Okay.
Try to move the oxygen in the middle. You will see. No, oxygen only accept
no,
two,
no,
remember?
wait. Okay. Here it is.
Say again?
Is good right now?
Yes, good now, but there's one more. So think about the fact that the C in the middle can move down to the bottom.
You mean like that?
Yeah.
Okay.
No. Okay, the C that connect to the OH.
Okay.
Can you move the C in the middle to that C that is connected to the OH?
Oh.
Yes, perfect.
Okay. Okay.
Right, okay, good. Okay, good now. So the first one, it's called propanol, or we call them propyl alcohol. The second one, it's called dimethyl ether.
Okay.
Wait. Oh yeah, the second one is called ethyl methyl ether, and the third one is called isopropyl alcohol. Good, you got it right.
Okay.
Okay, now I can share my screen again. And now we move on to 1.7, condensed structural formulas. So sometimes we want to save time. We can write condensed structure formula. So look at this one, dash formula. You have a chlorine here, 4C. You have a chlorine at the second C. So you can just eliminate all the dash. It's become condensed like CH3, CH, and then connect to the Cl here, and then CH2, CH3. Or even more condensed, you can write a Cl up here and then eliminate that dash. But to be honest with you, if it's too condensed, it's hard to see, right?
Yeah. Really hard.
It's quite hard to see. The condensed formula for isopropyl alcohol can be written in 4 different ways. So for this one, OH, you can condense like this, CH3, CH, CH3 here, and then OH. Or you can move the OH up there with a bracket. With a bracket, you know exactly that the OH is connected to the CH here.
Yeah.
But for this condensed formula, CHO, it's difficult to know, right?
Yeah.
So it's important to keep in mind that some condensed formula are really difficult to know exactly the formula. So you can write like this because they both have CH3 on the left and on the right. So you can write like this, CH3 2 times, and then CH, and then OH.
Okay.
The structure on the right, I think, is more easy to see compared to the one on the left.
Yeah.
Now, okay, you are asked to write a condensed structural formula for the compound that follows.
Okay. You wanna try it?
Yeah, please.
Okay. Wait. How can
Maybe just take a
let us
snapshot
take a
and then...
picture of that? Okay,
Yeah,
right
yeah.
here. Okay, let us share.
Mm-hmm.
Here will be CH3, CH, CH3, CH2, CH3. Okay, here we go.
I think so, yeah. Good. But now let's see the answer.
CH3,
Yeah, you got
CH.
one of them right. You got one of them right. Good. So either way works.
Why can I swipe it? Stop shit. Okay.
Okay, so you have a compound at practice problem 1.13, and you have to write a condensed structural formula for the following compound. Please look at it carefully. Look at it carefully, because sometimes bold structure can be difficult. How about you take a snapshot and then you try to write, okay, the C is the one is black, and all the others are just hydrogen.
Okay.
Take a snapshot and then, yeah. Okay, now you can share.
Okay. CH. C. Three right here. CH. C3. C3. Here. I confused like this one. Let us share my screen to explain it to you.
The CH3 on the right, you can say like CH3 2 times.
But I mean, wait, it's easier when
On the right, yeah, on the right you can see CH3 here, CH3 there, so you can write like open the bracket, CH3 2 times.
Yeah, I already picked that one, but I confused for that one, so let's explain for you by CMF3.
Actually, there are CH3 here and CH3 there as well, and on the here CH3 here as well. So you can write simply like this. Open the bracket, CH3, close the bracket 2 times, and then here. 1, 2, 3, okay. Okay,
it will be CH3 for 2 right now, and right here, I confused that one. This way.
Which one?
This one. This one. This CH.
Yeah.
Okay, CH. And this CH2. So confused, like this one is for that one or for that one.
Oh, are you sharing screen now?
Yeah.
Oh, sorry.
I confused like this one, this hydrogen is connected with that carbon or
no, it's connected to the carbon on the left. Yeah.
This one, right?
Yeah.
So it will be CH. And Here is have one more CH with CH3 and CH3 again, and with CH3. I guess so.
Let me see. 2 times. Okay, good. And then, on the right, you can just say like open bracket CH3 2 times.
This one, you mean?
On the right, yeah, 2 times, and then eliminate that last one. Yeah. There you go. Because they are similar, you can write 2 times. Yeah.
About that one?
Yeah.
Can I get C?
For that one, I would say maybe keep it that way because it's easier to see that way, I think.
Okay.
I told you one thing about these kind of condensed structure, it's harder to see, so
Okay, got
there's
it.
a limit to everything, you know.
Yeah.
Okay, now continue. Bond line formula. Oh, my favorite.
Yeah, I studied that with the lab in this morning, so I think I can do the practice.
How to draw? You know how to draw bond line formula, right?
Yeah, that's
Okay,
right. So I
now
want to try the practice problem 114. I think
you
I can
mean
do it.
okay, you can do bond line formula. Bond line formula basically just bonds and then any relevant atoms are there. Maybe try the write the bond line formula for this one.
Okay, let us stop share so I can see your.
Why don't you just snap a picture and then see?
Okay.
Yeah.
Okay. Right here. Let us try.
Okay, got it.
Okay, it's CH3, CH, CH3, CH2, 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 and OH. Okay, wait. C, 1, 2, 3, 4, 5, 6. 1, 2, 3. No, 1, 2.
6 carbon, right?
Yeah, and 1 O right now.
Right.
Oh, and okay, yeah,
4,
it's right
5,
here.
6. Oh, you have one extra carbon there. 1, 2, 3, 4, 5, 6. But you wrote down 7 or 8.
Okay, so it's just here.
Yeah. And write the OH over there. Yeah.
Okay, and this OH.
Yeah, good. Very good. It's just that. Yeah, good.
Do you want to
Very
try
good. You
the
got it right.
practice
Yeah.
problem?
Sorry?
Do you want to try the practice problem right there?
Why not? Yeah. That's 1.14.
Yeah.
Write each of the following condensed structure formula as a bond line formula. You know what? I think why don't you just snap a picture and put it on the note or whatever so we can see it when we write.
Okay.
Because I don't see it when you write. It's difficult for me.
Okay, here. Give me a second.
Okay. Just snap a picture and put it on a note or something.
Okay.
Okay. You can share screen. Oh, yeah, this one. Okay, bigger. All right, got it. Now let's write each one. Are you actually writing on like the laptops? What's it called? That little box below your keyboard?
Nah.
Are you writing
I don't use the keyboard for iPad. I used to do it, but
you have to have that board like something to write on, right?
yeah, that's right. But I used to use the keyboard with the iPad, but I think it's the feeling is not good like when we do the laptop, so I
You
return that.
mean not as good as when you are using your mouse, right?
Yeah, that's right. It's better when we it's so there's a difference between iPad and the laptop. Some
Oh,
different
forgot you use
things
iPad.
like
That's why you use iPad already. I see. So you use
yeah,
Apple Pen. You use Apple Pen as well, right? So
yeah, that's right.
correct. Okay, I see. That's why your handwriting is good now.
Yeah, that's right. Mm,
I think for A something's wrong.
okay, second to check it.
Oh, can you move up?
C
Okay.
three
CH3
one
two
two.
times. So for there should be a branch. There should be a branch.
Okay, got it. Wait.
Yeah. There you go. That's still a CH3. Good.
Yep.
And then C. Okay. Okay, got it. For B,
Mm.
branch. Yeah.
That I do here.
And then OH. No. Good. The feeling when you write on the iPad screen is actually very good.
Yeah, because
I
I
got a
practice
feeling.
in the morning for whole my morning, so because the lab it do it's too, and you know he want to do like on the type on the way to do the content structure. So for that I need to like here that I share for you.
Oh,
Where's
what
that?
time is it right now?
At the lab. For me is 10:30. Yeah, in
At
this
night?
morning I did need to do it like that.
Oh, I
Like it's
see.
a any way to do it. So he want me to list for all the way to do. That's why I study that for whole the morning.
I
That's why now
mean,
I
yeah,
be
this
done
is
with it.
a good exercise, I believe.
Yeah,
And it's fun to do.
yeah. I think it's good.
Okay,
No
now you have double
boring. Like
bond. Now you have double bond, yeah?
okay, here. Let I try.
Careful, careful, double bond. Ah,
Um,
no. The double bond is on the carbon on the left, yeah.
this one.
Yeah, that one.
Okay. B, C, one, two, one, two.
Okay, good now.
Okay.
Just have to be very careful for chemistry. It not only teaches you chemistry, but it teaches you how to be much more careful.
Yeah.
Yeah, because every single mistake can lead to disaster.
Yep. Wait. This for two, three CO2. Right? Here. Oh, just fine. One, two, four. Okay. It's correct for D.
Mm-hmm.
Okay.
D is the
Okay. Here we
easiest.
go.
Okay, there you
How about E?
go. E is actually good. Good.
Okay. F.
F.
Okay. Here we have found that one too. It's will under, right?
Second.
The double bond will be under the line.
Moment. Let me see now. So the double bond is exactly, I think under or upper, it's fine.
Okay.
It's all fine. Fine for me. Fine by me.
Okay.
And then branch and then branch out because you have two of the CH3, CH2, yeah?
Wait. This one, C2, C2,
Okay, you're making a mistake now.
C3.
I believe you're making a mistake now. But
I
I will let you recognize your own mistake, so that's why you learn.
Okay, wait. Like that way. But it's for 2 times, so one more thing. I'm not confident with that one.
Okay, so let me try this one. CH2, double bond CH. Okay. Let me try to share whiteboard.
You shared?
Yeah, I have my whiteboard sharing right now. So I would say double bond. Can you see it now?
Yeah.
And from this carbon, it branches out, right? Because you see like two times of something else, right? It branch out, right?
Yeah.
So 1, 2, another 1, 2. See, this is CH2, CH3. This is CH2, CH3 as well. So this is a correct structure. See again, if you have to rewrite it, this one will be CH2 and double bond C here, and then branch out CH2 and then CH3 and then CH2 CH3, right?
Yeah.
This is exactly what that condensed structure tells you. So be careful.
Okay.
Okay, I'm saying let me stop share. I'll see your share screen. Okay, how about the other one? How about the other one?
Okay, let us share. Here, the G. Okay,
Okay, G. Oh, where's your G? Where's G?
G here. Wait, let I fix that one first.
Yeah, branch out. Oh, don't touch. Correct. Correct.
Okay.
Correct. G.
Okay.
Oh, compared to like 13 years ago or 14 years ago when I first entered first year, oh dear. Writing on iPad and everything else, it's just like, you know, a dream. Because I remember in 2009, that's when the first iPad was ever launched.
Yeah.
And everyone was like, oh my god, I must get it. Yeah. That was when you were 7 years old, right?
Yeah.
And the 2009, oh my god, everyone was like a must-have item. Right now, 2009, summer. I still remember. Something wrong with the Cl. It should not be on the third carbon, it's on the second carbon actually.
Oh yeah, that's right.
You keep making this mistake, so I'm a bit worried.
Cl 1, 2.
Can you scroll up a little bit?
Yeah.
Okay, I got it. I think mom's calling.
Yeah, my mom.
Well, she's obviously worried. Obviously. Something wrong with H.
Okay, give me a second.
Because there should be a
1,
branch
2.
at the end. Should be a branch at the
Yeah,
end. So that's
that
why.
right here. It's not complete.
Uh-huh.
1, 2, 3, 4, 5.
And you
Hey,
have
wait.
one extra. You have one extra carbon.
Wait, yeah.
Yes, that's how it should
2.
be.
Yeah. Here we go.
Wait. Let me check again.
1, 2, 3, 4. 1, 2, 3, 4, 5, 6.
You still
1,
have
2,
one
3,
extra
4,
carbon.
5, 6.
You still have one extra carbon.
Yeah. Here this is.
Correct. So
Okay.
my advice is always recheck 2 or 3 times. Yeah.
Yep. Okay.
Okay. With chemistry, you can always make a mistake.
Yo. Okay.
What's that?
Okay, let's try the practice 116.
Okay, 1.15, right?
Yep.
It's asked you what molecules in practice problem 1.4 forms sets of constitutional isomers. So it means which one are constitutional isomer of each other. How do you know this one?
Dash formula only.
You see?
So this is a condensed formula, right?
Which one?
The direction?
Are you sharing screen now?
No, I mean for the practice 116.
Dash formula. Write a dash formula for each of the following bond line formula. This should be easy because now you just have to write like C dash H something, just write everything down. Just write every atoms out.
Okay.
That's what they mean by dash formula, yeah.
Yeah. Okay. Let I take a screenshot for that.
Let me.
Okay. Yes. Okay. Here we go. Here. Okay. So, like, I need to draw in the picture too. Like this. C, this, C, this, C, this, C, this, C. You mean like that?
Yeah, and remember you have H to fill in. And also you have to write a connection between the C and the H.
So it will have C, H, H, this C, this H, 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 right?
On the left it's not correct. And on the right it's not correct either. Should be like CH3,
This CH3. This CH3.
I mean, on the left and the right should be CH3, not CH2.
Okay. So
just write one more H.
H and H. Okay. It's correct right now?
Correct. Okay, let's go to B.
Okay, this C, 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 C. Oh no. Yeah, that's right. C. And this C2. And now
fill in the H, yeah.
C. no, H, this H, this H, 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 H,
I think you miss out on the C.
H, H, let us view data. This
Okay.
H,
Yeah, good. And on top, the C and no, that's more than enough.
just, oh, yeah, that's right.
Remember, C only form like 4 bonds, right?
H, okay.
Correct.
One,
Now,
two, three,
there's
four.
the C on
Oh, this one.
down there. Yeah, 1H. Good,
Yeah.
good. You got it right. Okay, C.
D, C, 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 and C. Okay, right here it should be. It's just 1H. This 3H. This 1H.
Good.
It was 1H too.
Okay, good.
2H.
2, yes. 2, good. And then
And this one 1H.
another one.
1H too.
Correct.
Okay. Okay. So then you can share your. We can move to 1.7. Yeah, I don't understand that one. Like
3D formula. So basically, this we are talking about 3-dimensional structures in space now. So we talk about 3D formula. So I told you before, in space they look different compared to on paper, right?
yeah.
So none of the formula that we have described so far convey any real information about how atoms and molecules are arranged in space. And we live in a 3D universe right now. So basically we have to represent them with something differently. So the ordinary line as a dash represent a bond that lies in the plane of a paper. So a piece of paper, like in a piece of paper like this. If they on the same plane as a piece of paper like this, then you represent them with ordinary line or a dash. However, if the bond project out of a plane of paper like this, out, get out. So you have to write a solid wedge. And if it projects away from a paper like this, away from a paper like this, you have to write dash wedge like that. So just to make it clearer for you before, I think. Okay, just okay. So this one and that one, it's pointing toward you, right?
The solid, right?
Yes, and this one is away from you.
The dash.
Yes.
Yeah.
Alright, so yeah, like I told you, this one is a typical example I already wrote in my video as well. I already gave it in my video. Now, so generally for carbon atom we have only single bonds. So four surrounding it. So it should be tetrahedral. Tetra means 4. Tetrahedral geometry, and the bond angle is approximately 109.5 degree. And you have to draw like dash wedge or solid wedge together with like the normal line. For the case of double or triple bonds, For triple bonds, it means that the carbon can now only connect to 3 things, right?
Yeah.
Because look at this one. Yeah. Triple bonds. So now the carbon can only connect to 3 things. And because of double bond like that, it has a trigonoplanar geometry. So basically, it's like this.
Okay.
Oh, like on the same piece of paper. So that's why we have the word planar. Plane, you know, the plane, mặt phẳng, plane.
Yeah.
Trigonal means like it form a triangle. Trigonal planar geometry. And the distance between them is of course separated by 120 degrees. For triple bonds, of course you have only one possibility. Triple bond, you can have only this. So
Okay.
linear, right? Line.
Linear.
Linear or linear, yeah. Wait, is it linear or linear?
Linear.
Let me
Because
check.
now I study linear algebra.
Oh my god.
Linear. Linear.
US, UK is all linear, yeah. Weird, right? It's linear. It's linear. And of course, because of linear, it's 180-degree angle. Last one, drawing 3D formulas for molecules. You draw as many carbon atoms in a plane of the paper as possible using ordinary lines. Then use dash or solid wedge bond for constituent group of hydrogen atoms that are needed to show 3D dimensions. So, for example, ethane. So first thing first, always draw the carbon first because they are the backbone, right?
Yeah.
So C, normal line, C. And then all the H is like, okay, should have like a normal bonds, dash wedge away from you, and then what is the bold one called? Solid wedge. So it's like you always need to have like 3 different types of connection, like here. Normal, dash wedge, and solid wedge, right?
Yeah.
Same thing here, up here. You can write it like vertical or horizontal, like this, etc. Many different types. For bromomethane, so it's like the rules like this. Hydrogen is not that much important compared to like bromo or anything else attached to it, right?
Yeah.
So when something is important, you put it in a normal line. Normal, okay? So that's why C normal BR.
Okay.
C normal BR, C normal BR. And then all the other hydrogen just like normal, dash wedge, and solid wedge.
Okay.
Okay. But of course, there can be other cases as well when you see OH, BR, whatever is like dash wedge or solid wedge as well, of course. Like these cases. Linear geometry. This one is like 120 because it's from a trigonal planar here.
Yeah.
This is linear, a line. This is what's it called? Tetrahedral. Okay, so you are asked to write a bond formula for the following compounds showing 3 dimensions at the carbon bearing the chlorine atoms. So this middle carbon bearing the chlorine atoms, you have to show 3D structure of that. You know how to do this? Okay, so look at the strategy and answer. You can say, first, draw the lines to the carbon skeleton first. 1, 2, 3, 4, and 5. And the carbon in the middle, you know that it's connected to the chlorine. Add the chlorine atoms.
Okay.
Here. So because the backbone of the carbon is normal line already, so they recommend writing chlorine and hydrogen as like solid line, solid wedge, or dash wedge, or flip it like this. Flip it like this. This is the easiest way. You sure you got it?
Yeah.
Okay,
It's
now
good.
you're asked to write 3D wedge dash wedge line representation for each of the following. All right. Okay, just snap a picture and then wait. Can you snap picture easily on iPad? Like small
Yeah,
little pieces and bit and pieces.
Yep.
Sometimes I feel like I'm just too old-fashioned.
No worry.
Yeah. Try to keep up with technology is sometimes difficult.
That's right.
I'm trying to think, like, should I just get a, what's it called? Window pad instead of like
Nah.
iPad? Why?
When you use with iPad, I make sure that you don't want to use anything except that, because
My
I have
brother
tried.
also told me the same thing.
Yeah, same thing. But for the running, for Windows, when you use for a long time, it will be laggy and it's
Laggy? You
really
say
slow.
Windows laggy,
Yeah,
right?
yeah.
But that doesn't
It,
mean that laptop iPads are not laggy.
but for iPad, I think for iPad Air and for iPad Pro right now, when they produce it, it's for studying. Almost is for that. So I think it's much better than the Samsung or the Windows.
Okay.
Yeah. I'm just a fan of Apple, so
Okay, fine. But as I'm not a fan of Apple, I know. I used to use Samsung phones, so
yeah, I used to use it too, but Apple is the best.
I mean, I
And
try to use iPhone and I try to use iPad Air, but it just something's just really off. So that's why I'm now still using Windows. Yeah.
oh really?
And you know that Apple, they charge for their products a lot of money. So
Yeah.
it's like sucking the blood out of people. I don't like it.
For the A, it's good.
Uh-huh.
Okay. For the B.
Okay, you sharing screen now?
Yeah, I'm sharing right now.
Okay, good. Right. Should one draw like dash wedge or solid wedge, you know?
Yeah. The A is correct.
Yeah, it's correct. One piece of advice. So when you draw for A, when you draw the CH and CCl on the
Yeah.
right part, try to draw them like 109 degree apart, right?
Oh, okay.
So try to
it's-
lean down a little bit, a bit down, a bit down. Yes, correct. Because in space they are like that.
Oh, really? Okay.
For the H that you draw with the solid line, it should be a bit down, you know.
Yeah.
Because in
Okay.
space it's like that.
Sure. Okay. Um. Okay. Here we go.
Something wrong. The C is still the middle. The still in the middle one. Yeah.
So B right here. This is here.
Yeah, I can do it like that. Yeah. Why not?
Here and this one.
Let's see now.
Okay, wait.
They said that, okay, so they said that focus on the C and the Cl, I think.
Yep, right here.
So
Right.
right.
CL.
Oh, are you next to someone? Are you living with someone or something? I heard noise.
No. I have not.
Okay, maybe it's just the reflection. I mean the
Does it correct?
echoes. Yeah, correct. I would say. Yeah.
Okay.
Okay, good now. Okay, we can go back now. Okay. Oh, so 1.8 is resonance. But maybe that's one for later, okay? It's already nearly 1 o'clock. So.
Okay. Yeah. This can be for.
Resonance is a bit more difficult to understand. We can do it later.
Okay.
So I'll see you on Sunday, no? Sunday morning.
Yeah, that's right.
Same
Sunday.
time, 10 o'clock. 10 o'clock
Okay.
Vietnam time, Sunday.
Okay.
Okay, I'll end the video here. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh để đăng ký kênh á, để mà các bạn có thể được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.